Chapter 1, Simple Inequalities. This is a supplementary lesson to our Unit 1, and what we're going to focus on is an extension to our equation solving skills, where instead of having two expressions equal to each other, we're going to have a mathematical sentence that compares two expressions. And that is actually the definition of an inequality. A mathematical sentence that compares two expressions. Now, in math, we use four symbols for comparison. Your most common ones you've heard of would be the less than and greater than. But we're adding into this the idea of something being less than or possibly equal to something. And then something that is greater than or possibly equal to something. As a part of this, I also want to point out that for inequalities, where we were just doing x equals a number, we'll have where x could be many numbers. If I said x is less than 5, well, then x could be 4, 3, 2, 1, and all the way back until negative infinity. If I'm talking about something being greater than 12, then I'm talking about 13, 14, 15. I bring this up because not only are we going to solve, but we're going to be graphing our outcome on a number line. And it would be helpful to talk about here, first off, how do we mark the location on the number line? And then we actually color in portions of our number line depending on which numbers are part of the answer. For our less than, we would put a circle around the number that we got as part of our answer. And that is because it's not actually part of the answer. If I said x is less than 5, 5 is not part of my answer. Only the numbers smaller than 5. And they are going to the left on the number line. And we'll actually use that to help us mark on the number line the direction of all the numbers in our solution. For numbers greater than, we would put a circle around the number that we get and shade all numbers to the right. So for instance, if I said 12, that we were greater than 12, I would put a circle at 12, and then I would color everything after the 12 to the right. For less than or equal to, if I said x is less than or equal to 4, when I put my circle on 4, I'm actually going to color it in because 4 is one of my answers. But so is every number that comes to the left of 4. For greater than or equal to, if I said it's greater than or equal to negative 3, I'd put a circle at negative 3, and then I would color it in because it's part of my answer. It could be equal. And then I shade everything to the right because that's where the numbers are getting bigger. We'll practice putting that on the number line with the 4 examples I have set up. And then I'll leave 2 at the end for you to try on your own. So where we're going to start is we're going to do each of our four properties of equality, only this time it's properties of inequality. The only way to keep the inequality true is to make it to where what I do on one side, I must do to the other side. If not, then my inequality is different. Let's start with the 13 is less than or equal to x plus 14. It says x plus 14, but I want to get x by itself, so I will subtract 14 on either side. Leaving me with an x on the left. Don't forget to bring down your less than or equal to. And then 13 minus 14 is negative 1. Before actually graphing it, one of the things I want to suggest to you is to take the inequality and put the x, or the variable, on the left side. Since I'm trying to figure out if x is greater than or less than equal to something, let's put x in front. To do that, I'm going to take this entire thing and I'm going to flip it so that x is on the left. It'll say greater than and then negative 1. This is going to help me make my number line. So on the number line, I try to do a minimum of 3 spots. And the middle will be negative 1. To the left of negative 1 would be a smaller number, so negative 2. And then to the right would be 0. Now my result had negative 1, so I'm going to put a circle there. But it did say or equal to, so it means I color in the circle. Negative 1 is one of my answers. But so are all the numbers greater than, so I would color in the number line to the right. What might be helpful is to think about what are all the possible numbers x could be. For instance, it could be negative 1, not negative. So from negative 1, then 0, and then 1, and then 2, and so on, which is now represented on the number line. Let's look at our next example. It says solve. X minus 5 is less than negative 3. Graph the solution. Well, it says x minus 5, so that means I'm going to add 5 to each side of the inequality. Now my x on the left is remaining. I'll bring down my less than symbol. And then negative 3 plus 5 would give me 2. So x is less than 2. What are all the numbers less than 2? Well, that would be like 2, and then 1, and then 0, negative 1, negative 2, and so on. So let's demonstrate that on a number line. On the number line, I'm going to put 2 right in the middle. Let's see, to the right would be 3. To the left would be 1. And I'll start by putting a circle at 2. Now I made a mistake. It says x is less than 2. Doesn't say equal. So 2 is not part of the answer. Which means I'm going to leave an open circle, but 1, 0, -1, all of those numbers are still part of my solution. And when talking about less than, we'll shade it to the left of our circle. So far, your steps remain similar to the equations we have previously solved. Let's now take a look at multiplication and division examples. Solve x divided by 5 is less than or equal to -3. Just so I have some space, let me write this out. It says x divided by 5. So what I'll do is multiply each side of the equation by 5. On the left, I'll have x remaining, and then my less than or equal to, and then -15 times 5 will give me -15. So x is less than or equal to -15. So -15 is part of my answer, but so is every number smaller than it. So -16, -17, and so on. Let's demonstrate that on the number line. In the middle, I'll start with -15. To the right of that would be -14, and to the left is -16. I'll start by putting a circle at 15, and 15 or -15 is part of the answer, so we color it in and then shade it to the left for all the numbers smaller than -15. One more example before giving you a few to try. 6 times x is greater than -18. So, since it's multiplication, we divide by 6 on each side. On the left, I have x, and on the right, -18 divided by 6 would be -3. This is every number greater than -3. It does not include -3. So it's numbers like -2, -1, 0, 1, and so on. So let's put that on the number line. At the center, I'll put -3. To the left, that'd be -4. And to the right, that would be -1. I'll put my circle on the graph. But -3 is not part of my answer. So for the numbers greater than, I'm just going to shade it to the right, where the numbers get bigger. Go back and watch any part of this video that you think you might need a little bit of help with. When you're okay with that, come back and then check out the 2 try it questions that go with this page. Alright, I have the 2 questions. Pause the video and try them out, then come back and check your solution.